Welcome. In this video, we will see slanting grounding electrode technique for reducing the grounding resistance of a substation. In last video, we seen basic methods for decreasing grounding resistance. Link is available in description box. In last video, we studied below basic methods for decreasing grounding resistance. 1. Increasing the grounding grid. 2. Connecting the main grounding grid to an extra external grounding grid. 3. Increasing the burial depth of the grounding grid. 4. Utilizing natural grounding bodies such as the steel foundations of structures. 5. Increasing long vertical grounding electrodes and 6. Replacing the soils around the grounding grid for low resistivity materials. The basic methods to decrease the grounding resistance of a substation are to expand the area of the grounding grid or develop in a vertical direction, for example adding vertical ground rods to the grounding grid. In this video we will see slanting grounding electrode method. A slanting ground rod, which has the merits of both deep vertical grounding electrodes, and area enlargement without land expropriation, as shown in figure. Compared with vertical ground rods, the shielding effect among slanting ground rods is very small. Thus, for the grounding grid, using a slanting ground rod to decrease the grounding resistance is more effective than applying vertical ground rods with the same length. When the resistivity of deep soil is higher than that of the surface soil layer, the effect of equalizing the potential and reducing the grounding resistance by slanting ground rods will be better. For a grounding grid with an area of 55 meter by 55 meter, the conductor spacing is 11 meter, the soil resistivity is 90 ohm meter and 4 number of 50 meter slanting ground rods are arranged at the 4 corners of the grounding grid as shown in figure. Changing the slanting angle of the ground rods, we can get the grounding resistance and the maximum step voltage shown in table. Let's see scenario 1. When the slanting angle is 0, it means the grounding electrodes are arranged vertically, but if slanting angle is 90, it means the grounding electrodes are arranged horizontally. Obviously, adding slanting electrodes has a greater effect in reducing the grounding resistance and step voltage compared with vertical rods and horizontal electrodes. When the slanting angle is in the range from 30 to 60, the effect is better, which you can see in this table. Let's see scenario 2, with a grounding grid area of 200 meter by 150 meter, the grounding resistance of the horizontal grounding grid is 0.45 ohm, without slanting grounding electrodes. When 8 vertical ground rods having length 100 meter, and 8 slanting grounding electrodes having length 100 meter, slanting angle to the ground 25 degree are added, to the 4 corners and the midpoints of the 4 sides of the grounding grid, the analyzed grounding resistance becomes 0.25 ohm and the measured grounding resistance was 0.265 ohm. Balance techniques to be discussed are using long vertical ground rods, explosion grounding technique, deep ground well. Stay tuned, we will discuss these in upcoming videos. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.